So, to move on to recording number 3 here, we found when we finished doing our ANOVA before that there was a statistically significant difference. But the problem is we don't know which groups are significantly different than each other. And one option that you could choose to use here is you could actually start doing a bunch of t-tests and see which groups are different than each other. But there's a problem with that, and you need to take a few notes on this very idea. The problem with that is just by running a few t-tests, you'd actually have to run a whole lot of t-tests, and there's a good chance you could make what's called a family-wise type 1 error. And a family-wise type 1 error is basically the idea that if you just run a bunch of t-tests, you'll run so many that you might find something significant just because you ran so many, and it might just be due to chance. So we don't like to just run t-tests after we get significant ANOVAs. The approach that we use to fix that problem is there are a number of tests, and your book actually has a whole bit on this information. There's a bunch of tests that we run, and they could be called basically post hoc tests. Post hoc is after the fact. And a post hoc test, there are many different types that you can run, but a post hoc test is like a t-test, but it's simply more conservative. What I mean by more conservative is that you really need to get a big difference to say there's a significant effect. And so there are a whole bunch of different types of post hoc tests we could run. The most common, or one of the most common types to run, is based out of a famous statistician. His name was Tukey, as opposed to the Thanksgiving holiday of Turkey. And so the one I actually ran here with SPSS was called a Tukey post hoc test. HSD stands for honestly significant difference. It's called a Tukey post hoc test. And if you look at that printout, what you see in the first cell is basically, if you go across the first row, it's kind of comparing groups 1 and 2. So group 1, the mean was what? 5. The group 2, the mean was 4. That difference is 1. And then it says sig 0.662. The difference between the mean of group 1 and the mean of group 2 is not statistically significant. You're looking for something less than 0.5. If you look at the second line, it's the difference between the group 1 and group 3. That difference is 2. That is also not significant. If you look at the third line, it's the difference between group 1 and group 4. So group 1 had a mean of 5. Group 4 had a mean of 1. That difference of 4 with this Tukey test, P equals 0.001. So that is a statistically significant effect. So it kind of looks like, if you look at the different means there, group 4 is really going to be the one that's really going to kind of light the day here. And if you go down to the bottom of that chart, you can see that it starts with group 4. Everything is basically done twice on this chart. Notice the difference between group 4 and group 1. That 4-point difference is statistically significant with the post hoc test. The difference between group 4, the high dose, and what the moderate dose is also statistically significant. The difference between the high and the moderate dose is not statistically significant. So you run a post hoc test to basically find which groups are significantly different. And a post hoc test is like a t-test, but it's simply more conservative. So with that basically said, let me get to the homework in this situation that I want you to do. First, homework number 1. Basically take that problem that I've written out. I got a simple example here: no drug, low dose, high dose. And basically write out statistical and real world and just enumerate what all these numbers mean, and if you want them to be high and low and so forth. And then go to the Tukey post hoc test and say what that's basically specifying about these different groups. So this will demonstrate that you actually have the knowledge. And then homework problem number 2 is going to be a little more challenging. I actually want you to do a 1-factor ANOVA by hand. Now you did this, I think, once before in the previous unit, but in this one you've got high drug 11, 12, 13, low drug 4, 5, and 6, and no drug 3, 4, and 5. So to do the ANOVA here, you'll need to get the means of each group. That should not be difficult. And then compare them to the grand mean and do your math there. Remember what the sums of squares are within group when you have 3 consecutive numbers. So see if you can do that workout, send me a draft, and we'll look at things. And then you don't have to do a post hoc test, but if you did, say what the probable results would be. So hopefully this all makes sense, and I hope it goes well for you. Thank you all very much. Bye-bye.